Hello, good evening, and welcome to our virtual interactive biology science experiment today that we will be doing for you. My name is Megan, and this with me is a very special guest. Of course, he is
My name is Joshua Lopez.
Joshua Lopez, that is, and he is my son. We will be doing this experiment together for you. So before we start the experiment, as always, we will have to go over the safety rules. And this is very important. This science experiment will be very fun, easy, and simple, but there will still always be safety rules to it.
Yes.
So as number one, we'll start with, and what will that be, Joshua?
Always wear safety goggles.
Safety goggles.
And if you do not have safety goggles at home, you can wear any type of sunglasses or some shades to work with this.
Absolutely, you are absolutely right. So it is a-okay if you don't have the proper safety goggles. And rule number two will be
always wear safety gloves. And if you do not have safety gloves like these, you can wear any type of gloves at home.
Any type of gloves will work. Now that we have our safety gloves on, so rule number three for this experiment will be
is always have your proper materials to do the project.
yes. Always make sure you have the proper materials. And in this experiment, our materials, we kept it to a minimal of 3 simple materials. And those will be?
We will be using water, tap water. You can use any type of water.
Yes.
We are using oil. We're using canola oil, but it's okay to use any type. And we are going to be using dish soap. Any kind will work as well.
Yes, so these are all very simple ingredients that I'm sure your parents have in the house, and you can use them and come along for your experiment. We are going to be learning through this experiment about the emulsion process and the term emulsifier, what an emulsifier is, and how the emulsion process works using our ingredients, dish soap, water, and oil.
Well,
now,
that sounds very interesting.
It sure does. Now, with that, can anybody here tell me what a hypothesis is and why a hypothesis is something that comes up before a experiment is performed? Oh, do we have answers here? I see. So, Joshua, yes. Can you tell the students at home?
Well, a hypothesis is a guess, an educated guess. Give it a try. Don't be shy. Do your best. It's a guess.
Oh, excellent. That was great. So Joshua described very well what a hypothesis is, which it's an educated guess. And Joshua, and for the students at home who don't know, would you be able to tell them why a hypothesis is needed before the experiment is performed?
Well, because hypothesis, you get to think of what will happen, and then you get to see what actually happened, and you could compare your hypothesis with the actual experiment that
with
finished.
The results,
yes.
Right? Yes, Joshua is on a roll today. That is excellent. So Joshua did a very good explanation of what a hypothesis is, and that is an educated guess. So Joshua, you did a very good a song for our students about hypothesis. So can you tell me what is your specified hypothesis for this experiment that we are going to do?
My hypothesis is oil and water will not mix, because I have not seen any experiment with oil and water not mixing with any other substance or liquid with it. So that is my hypothesis.
Oh, excellent. So Joshua made a very wonderful educated guess hypothesis for this experiment we are going to do. So our first step will be to mix the oil and the water we have here together. So Joshua, you are my assistant, so can we uncap both of these substances, please?
Yes, I will. Gotta be careful.
Very careful, absolutely.
So now I need a spill.
Not at all. So once we do that, we are going to take the oil out of the cup, and you are going to be very careful and mix it in with the water. And both of our measurements were made out to 3 milliliters. We did keep it equal oil to equal water.
And it is all in though.
Excellent. So you could just put it right back here.
Okay.
Red cap is oil.
Maybe make it
Put
a
this
little
right here.
higher so they can see the water and oil.
Well, we have to give that a shake up. So we'll twist this back, and then Joshua is going to shake it here up for us so our students can see. Joshua, just like
Thank you for
that.
letting me shake it.
Of course. My pleasure. Give it a few good shakes. Make sure you would shake it up enough where it would mix.
And
Or where you would think it would mix.
I think this should be good enough right here.
Okay.
It seems
So now
like
that you mixed it, we do have to let it settle first.
Yes.
So we are going to time it. So for a good 60 seconds from now, and we will see if our oil and if our water was able to mix, and if indeed Joshua's hypothesis is correct.
Yes.
So we are back. 60 seconds has passed. So 1 minute on the clock, and I am going here to show the results, and Joshua is going to explain them for our students at home. And you can go through your results right along with us if you are doing the experiment.
Well, I
Oh,
see
very
that the
interesting.
water is at the bottom and the oil is at the top, and the water is giving a cloudy, icy kind of look.
Like tone to it, right?
Yeah.
Yeah, absolutely. So we can see, right, Joshua? You can see
Yes.
the differentiation, the line where the top half is the oil and the water is the bottom half. It has sunken. Oh, that is very interesting. So Joshua, it seems like your hypothesis or your educated guess was actually right on target. So it
Yes,
seems
it
that it is
was.
not mixing, and that perhaps indeed it may take another substance, maybe dish
Some
soap.
dish soap.
Yes, to allow that to mix. But a question we hadn't answered is why doesn't oil and H2O is simply no? Why does it simply not mix? And we didn't go over that. So we're going to go over the answer now. So, and that is because, oh, and H2O is also the scientific name for
Water.
yes. And so H2O molecule is actually made up of 1 oxygen atom and 2 hydrogen atoms.
That is very interesting.
Yes. So what that essentially means is that it gives one side of the water molecule a positive charge and the other side an electronegative charge.
Ooh.
And actually oil is a fat. And the scientific term for fat is lipids. And a lipid, you can see here in the slide, is actually made up of a phosphate head and then 3 fatty acid tails for you. And the lipid does not actually contain that property. So instead of it being able to attract to the water and be attracted to it, it actually repels against it.
What does repel mean?
What does repel mean? Well, repel actually means to go the opposite direction. So,
Kind of like running away.
yes, kind of like running away. It does not run towards the water. Instead, it is running away from the water.
Yes.
Very, very good. So now that we can clearly see the separation and how the oil and the water has not mixed, we are going to use our
Emulsifier, which is our Dawn dish soap.
Dawn dish soap. And that is our third material. It was oil, water, and
Dish soap.
dish soap. And so this dish soap is going to be used as our
Emulsifier.
emulsifier. And so all we are just going to insert a droplet of Dawn dish soap into our tube here of our separated oil and water mixture.
1 drop is all it takes.
Yes, just 1 little droplet. Let's see right here. Okay.
I think we got it.
Oh, got it.
We
Wonderful.
have got our
So now we would just put our lid, screw it back on, and Joshua, do the honors, please.
I will shake it. And
Yes.
I think my hypothesis for this will be it will turn out very bubbly because regular dish soap mixed with water is usually bubbly. And I think with the oil, it will give more bubbles than usual, and maybe the color will be a little slightly different. than what it will probably be usually.
You are giving a very good description because not only did you talk about the color that he may see, the change in color, he also talked about the texture and the bubbles that we may see perhaps through this liquid. So I think that's enough shakes right now, Joshua. We can set it right through here. And once again, instead of 60 seconds this time, we have to let it settle, but we're going to give it a little longer because of the bubbles. So we're going to see you back here in a minute and a half and see our results. So we are back and we did let it set out for a minute and a half. That is 90 seconds. And I'm going to take out our mixture over here, a combination, and I'm going to show it to the camera. And I hope you students are doing this at home as well.
Yes. So I see it has bubbles all around it.
Oh, yes.
Show it a
Very
little
good.
down so that you see all the bubbles.
Oh, yes. All the way from the top.
And look at the very bottom. Our Dawn dish soap was blue and our oil was a light green. It's kind of like yellow. And now with that mixture, it looks kind of like a light green, kind of toning into a darkish green.
Yes, excellent. So Joshua did a great job once again describing the texture.
Thank
And
you.
he was pretty spot on. And it did turn our substance green. And that actually is how the emulsion process worked through this experiment and how the dish soap acted as the emulsifier that was needed in order to be the mediator. Well, mediator is kind of a big word. So how would we explain that to our students at home?
Well, you can say a mediator allows friendship, allows water, oil, and the dish soap to be friends and mix.
Absolutely. You'd set a great analogy for that. So an easy way for you to remember the dish soap being the emulsifier, how that acts as a mediator, is just to remember the mediator allows for friendship. So the oil and the water will be able to become friends and become one and mix together. That is a wonderful definition you had for our students.
Why, thank you.
Now you're going to ask me, why is that?
Okay. Now, why is that though?
Now, why is that, you ask?
Yes.
Well, that is because the dish soap molecule has what we call a phospholipid bilayer. And as you can see here, you can see an image of the phospholipid bilayer. And bilayer, or bi meaning
Two.
two.
Because you can see there's 2 layers.
2 layers. You have the head, and then you have the 2 chains down here. That is the tails. And so it actually is able to, because of the phospholipid bilayer, it's actually able to allow for the attraction of the oil. It has the oil properties, and it's able to attach to the H2O molecule properties and allow for that mixture or that friendship. Absolutely. Yes. So that is our experiment for today of how the emulsion process worked. And I hope you all had fun. I hope it was a simple experiment for you to do at home. And an important science note to take away from this is to know that the emulsion process is much more important than just allowing for the mixture of oil and water.
Ooh.
Did you know that?
Not yet, no.
Yes, and that is because of the small intestine inside our organs. And do we know what the small intestine is?
Why, yes, I do know the small intestine.
Can you please tell our students at home?
The small intestine is responsible for digestion.
Absolutely. The small intestine is responsible for digestion and absorption, but we are focusing on digestion today. And so through that is we have something in our bodies called bile. And bile is a substance that's stored in our gallbladder. But what the bile does, the bile is responsible for breaking down the lipids that we intake, and that is how we are able to digest lipids.
That is very interesting.
Yes, and a fun way for you to remember bile is if you can remember bile and file. And instead of emulsifier, just put emulsifier equals
Bio. Emulsifio equals bio. Bio rhymes with bio.
Absolutely. Great. That is a wonderful, wonderful way for you to remember that that is what's responsible for the breaking down of the lipids that we intake and to be able to digest that through our small intestine. So I think that sums it up for our biology science experiment today. We will see you here next time with Megan and
Joshua.
On our virtual interactive science experiment.
Bye.
Bye-bye.
Bye.